Hello, hello, my dear friends. Anyone in live? Anyone in live? Hello. If anyone in live, hi Suhas, hi. Is the video and audio is clear, Suhas? Is the video and audio is clear? Is the video and audio is clear, everyone? The one who are in the live, once you say me hi. Is the video and the audio is clear? Yes, sir. Okay, fine, done. Right. Clear. Right. Now, almost 35 to 40 questions I brought by covering the all the questions of the which one haloalkenes, haloarenes from the basics to the high level. Now don't be hurry up, okay? Don't be in hurry up to give the answer. See the question, see the structure, see the molecule. Now which one will be the major and which one will be the minor, that all you have to be very careful with this one, okay? Then don't be in hurry up. Don't be in the hurry up to give the answer. Hi Rishika, hi. Rest any other? Right. Now we'll wait for the few minutes so that rest others can join. The rest others can join. Okay. But don't be in hurry up. Don't be in the hurry to give the answer. See the structure, see the molecule. Now where it will attack, where it will go. You have to be very careful which type of the reaction they are asking, what is the mechanism it is involved in it. Now whether it will do the SN1 reaction, whether it will do the E1 reaction or E2 reaction. Clear? Right. Now just we'll wait for the few minutes so that the rest others will come. You have to be very careful with the structures also. Hi Praneeth, hi. Hi. Now be careful with the structures also. Now which structure they are asking, on what basis they are asking. Right. Okay, fine. Now we'll go with the questions. We'll start the questions. Okay, you know, right? If you know the answer, try to give the answer. If not, give the question mark so that in the less time we can cover the more number of questions. If you are not giving any response, I will think that you are trying the questions. Okay, it will make the extend. So much time it will take. Is it clear? Now everything is clear, right? Now should I start the questions? Everyone, should I start the questions? Shall we start? Everyone, shall we start the questions? Yes, right. Done. Now we'll move to the first question. Right. See the first question. Now say me the answer. See the first question and say me the answer. Yes. See the first question and say me the answer. Right. Is the questions are clear, right? If any questions, if it is in the blur or anything, if it is anything is happening, try to say it to me. Answer is D. Benzyl chloride, ethyl chloride, chlorobenzene, isopropyl chloride. Answer is D. Why? Why the answer is D? 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 Because 3-degree propyl chloride will provide this 3-degree isopropyl chloride will provide the clear 3-degree. So the answer is isopropyl chloride. Isopropyl chloride will provide the 3-degree. Right? Now, next. All right. Now, next one. Many of them they know or they don't know, I don't know. But then, what is the answer for this one? What is the answer for this one? What is the answer for this one? Chloropicrin is obtained by the reaction of. Chloropicrin is obtained by the reaction of. C sir. Chlorine. Picrin అని ఉందని చెప్పేసి పిక్రిక్ యాసిడ్ సెలెక్ట్ చేసుకున్నావా ప్రణీత్? పిక్రిక్ యాసిడ్ ఉంది కదా ఆప్షన్ లా అని చెప్పేసి ఇన్స్టెడ్ ఆఫ్ OH దెర్ విల్ బి ద Cl ఆన్ పిక్రిక్ యాసిడ్. కాదు నాకు తెలుసు నువ్వు ఇక్కడ పిక్రిక్ యాసిడ్ ఉంది కదా అని చెప్పేసి సో ఆన్సర్ పిక్రిక్ యాసిడ్ అని సెలెక్ట్ చేసుకున్నావు కదా, కానీ ఆన్సర్ అది కాదు. ఇట్ ఈస్ నాట్ ద ఆన్సర్. ఓకే, ద ఆన్సర్ ఈస్ డి. ఇవాళ పెట్టినా కదా గ్రూప్లో, సో ట్రై టు రీడ్. ఒకసారి అవి కూడా ఒకసారి రివైజ్ చేసుకోండి. ఆ పిక్రిక్ యాసిడ్ అదేంది పాలీహాలోజన్ కాంపౌండ్స్ ఆఫ్ ద haloalkanes, haloarenes are important. This is formed by the chloroform plus nitric acid. Chloroform, when it has reacted with the nitric acid, it will give the chloropicrin. This is the formula of chloropicrin. Okay, fine. Sorry. Okay, I will speak in English itself. Okay, done. Okay, fine. Right. Actually, the answer will be the D, because the chloropicrin will be obtained by when it is reacted with the chloroform and the nitric acid. Is it clear? Nitrochloroform we used to say. Another name of the chloropicrin, we used to say it as a what? Nitrochloroform. Okay, fine, done. Right. Is it clear? Right. We'll move to the next question. Right. Now see the reaction and try to say me the answer. See the reaction and try to say me the answer. Okay, fine. Right. What is the answer? What is the answer? What is the answer? What is the answer? CH3Cl upon NaCN gives A. Rest any other? Any options? Is the options are clear? Should I enlarge that question? Is it clear, right? Question is clear, right? Should I enlarge? Answer is A. Rest any other? Rest any other. Rest any other. Only two are responding. One Suhas and the other. If you don't know, give me the question mark. I will explain. Actually, if you know the answer, so there is no need of me to explain that question, because I can move to the next question, so that in the less time we can cover the more questions. Rest other, if you don't know how that conversion, this question it will come, I will explain. Rest any other? Right, fine, I will explain. Listen. Now, in this question, first CH3, CH2, Cl upon NaCN they have given, right? Na plus and the Cn minus. Now the Cn minus, it will go and attack and the Cl will be eliminated. Then we will get the CH3, CH2 and the Cn. Now next we are having the metal in the presence of H2. Metal in the presence of H2, what it will do? It will, metal in the presence of the H2, it will convert the cyanide into primary amine. It will convert that cyanide into the primary amine in this manner. CH3, CH2, CH2 and NH2, primary amine. It will convert that CH into the primary amine. Is it clear? Then after that, next question what he is asking? Then this with the acetic acid. This one with the acetic acid. How the acetic acid will be? Acetic acid will be in this manner. Now this is a acetic acid. This is a acetic acid. Now in this acetic acid, nitrogen, here this oxygen, this bond pair of electron, it will be abstracted, or from the solution H plus it will be taken, and it is this bond pair of electron will be eliminated. And here it will get the, which one? Carbonyl carbon. At deficiency you will get this nitrogen lone pair of electron will stabilize that carbonyl carbon. Then when it is stabilizing, here the CH3, here the CH2, here the CH2, next here the nitrogen will get the positive charge, then after the carbonyl carbon. Then to stabilize this nitrogen positive charge, it will given the bond pair of electron towards itself, so that we will get CH3, CH2, CH2, NH, C double bond O, CH3. That is the option number. That is the option number 1. CH3, CH2, CH2, NH, C double bond O, CH3. Is it clear? Is it clear? So the option number 1 is correct. Right? Is it clear? Done. We'll move to the next question. Chlorobenzene reacts with the magnesium diether to give a compound A, which reacts further with ethanol to yield. Can you show the slide again of the mechanism? You can see. You want to copy without knowing how you have said? Pranit, without knowing this reaction, how you have said the answer? Done? Is it clear? Done? Should I move? Should I move? Done, so done. Right. Now what is the answer? Now what is the answer for this question? What is the answer for this question? Chlorobenzene reacts with magnesium and dry ether to give a compound A, which further reacts with ethanol. What is the option for this one? What is the answer for this question? Okay, each question will take the 1 minute. Okay, each question will take the 1 minute. Now the time is 7:14, right? By 7:15 you have to send me the answer. Each question I will give you the 1 minute. What happened? See, sir. Once again you cross check. No. Once again you cross check. Once again you cross check. Rest any other? Any other want to give the answer? Both C and A are wrong. Both C and A are wrong. Rest any other? Answer is B. Here now here what he has given? Chlorobenzene. Chlorobenzene, right? Chlorobenzene he has given chlorobenzene. So chlorobenzene when it has reacted with the magnesium in the presence of, which one he has given? Magnesium in the presence of dry ether. No, answer is B. No, answer is B. When the chlorobenzene, when it has reacted in the form of magnesium in the dry ether, I thought you have made it as a diphenyl ether. I think you guys has made the diphenyl ether. This is not the Woods reaction. This is not the Woods reaction. This is not Woods reaction. Clear? Now the magnesium dry ether, what it will do? This magnesium and the dry ether, then it will come into the Grignard reagent. It will convert into the Grignard reagent. It will convert into the Grignard reagent. Chlorobenzene, magnesium triether, it will convert into the which one? Grignard reagent. Then after the conversion of the Grignard reagent with the ethanol, what? CH3, CH2 and O and H, it will readily give the H plus to the solution, right? Now here it is a partial positive and here it is a negative. Alkali will be the negative, benzene will be the negative, and here we are having the acidic proton that it will go and attack to the benzene, and it will the what? Magnesium O CH2 CH3 and chlorine will be the side product. Magnesium, now this one will be the side product and the benzene it will go. So the answer is B. Is it clear? Is it clear? Right, done. See the option carefully, don't be hurry up and try to say me the answer. In compound X, all the bond angles are exactly 109 degree 28 minutes axis. In which case the compound X, all the bond angles B. Right. Good. B only. See what I said, only one shortcut I said in the class. What is the one shortcut I said? Now central atom with all four are all same atoms attached without lone pair on it. Without lone pair on it. Here it's mu is equal to 0. And next thing I said, all the hybridized orbital without lone pair of electron on the central atom also will leads to give the dipole moment 0 as well as the bond angle also. Here you can see the carbon tetrachloride bond angle is 0. All are the 109 degree 28 minutes, so that its a dipole moment vectors will be cancel out. Now this iodoform reaction is also very important. Now what is the formula of iodoform? Can anyone say what is the formula of iodoform? What is this iodoform formula? What is the formula of iodoform? What is the formula of iodoform? CHI3. Good. This is the formula CHI3. What is the color of this one? What is the color of this one? What is the color of this one? Don't know. Yellow color. Yellow color is a iodoform. Now, what are the main criteria any compound to show the iodoform? Yellow. What are the main criteria any compound to show the iodoform? No, yellow color, not pale yellow. Yellow only. You can take. Now, what are the main criteria any compound to show the iodoform? What are the main criteria any compound to show the iodoform? What are the main criteria to show the iodoform? What it should be there? What it should be there? What is the main criteria? This is very important. Iodoform reaction is very important, my dear friends. I am saying you. What are the main criteria? What are the main criteria to show the iodoform reaction? Oxidizing. No. Wait. I will ask you. Will this show the iodoform? Will this show the iodoform reaction? Will this show the iodoform reaction? Will this show the iodoform reaction? Yes, sir. Done. Next. Will this show the iodoform reaction? Will this show the iodoform reaction? Now, will the second one will show the iodoform reaction? Will the second one will show the iodoform reaction? Second one, no. Third one? Third one, yes. Any compound to show the iodoform reaction, at least it should have a OH attached carbon. OH attached carbon means 1 degree alcohol and the 2 degree alcohol. 2 degree alcohols iodoform reaction will be shown. 2 degree alcohol iodoform reactions will be shown. Next, fourth one you have to say me. Okay, I will take it. Will it show the iodoform reaction? Will it show the iodoform reaction? Fourth one, will it show the iodoform reaction? No, because here it should be have the C double bond O CH3. It should have the C double bond O CH3. If it is oxidized also, these methyls are having only 2 hydrogens. So 1 degree alcohol and the 2 degree alcohols are distinguished by the which one? 1 degree alcohol and the 2 degree alcohols are distinguished by the iodoform reaction. So you have to be very careful. Is it clear? 1 degree alcohol and the 2 degree alcohol can be distinguished by the iodoform reaction. Right. Now you say me, I will write a one question. We'll write a one question. How to identify vicinal halides and geminal halides. Vicinal halides and geminal halides. How to identify the vicinal halides and the geminal halides? This one. Now, with the help of which reagent? Alcoholic KOH or aqueous KOH? To identify the vicinal dihalides, vicinal halides and the geminal halides, can be identified by the alcoholic KOH or aqueous KOH? Can anyone? Alcoholic KOH vicinal. Okay. Then okay. Right. Now vicinal dihalides, if they are given, if the alcoholic KOH, aqueous KOH, if they are given, very fastly it will be reacted. Not alcoholic KOH, aqueous KOH. Right. Next one, this one. Next question. Hello Ashwant. Hello, you are late to the live. Almost 25 minutes you have late. Almost we have finished 6 questions. Almost 6 questions we have finished. Now try to give the answer for this one. Try to give the answer for this one. C7H8, 3 moles of Cl2, 3 moles of Cl2. Now what is the answer? What is the answer? Answer is A. Answer is A. 3 bromo 2, 4, 5 trichlorotoluene. Trichlorotoluene. No. Not A. No. Once again you cross check. Answer is not A. Answer is not A. A kaadu answer. Answer is the not A. Can you explain this question, sir? Okay. Right? Should I explain or will you try? Alright, listen, I will explain. Now first one is a toluene. This is a toluene, right? Because what he has given? C7H8. This is a C7H8. 5 hydrogens. Here 5 benzene, 5 hydrogens, 3. Clear? 8 and 7 carbons we are having. Then 3 moles of Cl2 heating. 3 moles of Cl2 and heating if they are given. Good evening Astrid, good evening. Then we know, right? This is a free radical substitution reaction will be happen. Now free radical substitution reaction will be happen where? Now where the hydrogens are there. Here the 3 moles of Cl2 means 3 chlorines will be replaced. 3 chlorines will be replaced. Okay, no problem. Now be in the live and try to give the answers. Okay. Now this is a trichloro. Now this is a trichlorobenzene. Now this is a CCl3 is a strong, which one? Strong minus H effect. It will show the strong minus H effect. Now due to this strong minus H effect, it will show the meta directing. Next, Br2 is a electrophile. We know Br2 in the presence of Fe, Br3, Br plus as the electrophile it will generated and it will go to the meta directing. In this manner the meta directing it will go. Then after the meta directing, when it has went, then we are having the ZnHCl. Zn in the presence of HCl. Zn in the presence of HCl. Now what it will do? Alkali halide in the presence of Zn and HCl, it will restore it into the alkane. Again it will be restored into the alkane. Again the toluene will be generated. Already I explained you, right? Alkali halide in the presence of Zn or HCl. Now alkali halide, it will take the bond pair of electron and it will be eliminated. Now carbon, this alkali halide will get the positive charge. Zinc, it will readily lose the 2 electrons in the solution. That 2 electrons was gained by the alkali and again it will convert it into the carbanion. After that HCl, it will give the positive charge. That positive charge, it will go and attack to this one. Again the alkane will be restored. Here also same. It will be eliminated. Zn 2 electrons will be given and the H plus will be added. Again the Cl will be eliminated. Again Zn, it will give the 2 electrons. Again the H plus will be added. Again this Cl will be eliminated. Again that Zn, it will give the 2 electrons. Now asterisk, direct questions. These questions are very 3 moles sir. Excess it will be there. 3 moles and ivadu. 3 moles and mention cheyadu. Nenu already in the starting itself I explained very clearly. When it comes to the chemistry, the moles they will not mention because the Zn and the HCl it is a plenty. In the plenty you have to consider. Clear? So the answer will be the metabromotoluene. Answer is metabromotoluene. కన్ఫ్యూజ్ అవ్వద్దు, నేను అందుకే క్లియర్గా చెప్పిన స్టార్టింగ్లోనే. రష్ అవ్వకండి ఆన్సర్. డోంట్ బి రష్ టు గివ్ ద ఆన్సర్. సీ ద ఆప్షన్స్ కేర్ఫుల్లీ. మెనీ ఆఫ్ ద క్వశ్చన్స్ ఆర్ విత్ ద IUPAC only. IUPAC only the questions. Even though if you get the product also, sometimes if you don't know the IUPAC, it will give you the wrong. See how the questions they will stress examiner. Okay, you have to be very careful. Chudu how this is actually these reactions are of the preparations of haloalkanes, haloarenes, but the many part of the reactions are coming from the hydrocarbons only. Hydrocarbons reactions only keep on repeating. Right? Okay, right. Shall we move to the next question? Is it clear? Is this mechanism is clear? Everyone? Is this mechanism is clear? Shall we move to the next question? Shall we move to the next question? Shall we move to the next question? Is this mechanism is clear? Right, done. Trichloroacetaldehyde CCl3COH reacts with the chlorobenzene in the presence of sulfuric acid and the product is. Actually, I hope this is clear. This picture is clear, I think so. This question is clear, I think so. Question clear, right? Right, done. Try to give me the answer. Try to give me the answer for this question. Try to give me the answer for this question. Trichloroacetaldehyde means choral. This is choral. We know, right? Choral. CCl3 aldehyde. Choral. Choral. This is a choral. Choral reacts with chlorobenzene in the presence of sulfuric acid produce. Answer is D. D. What is this D? What is this name? DTT formation. Yes, good. Dichloro-diphenyl. Dichloro-diphenyl trichloroethane. Dichloro-diphenyl trichloroethane. Yes, diphenyl. No. Dichloro-diphenyl trichloroethane. This is DTT. This is DDT. DDT. Yes. Answer is D. Good. Everyone, is it clear? Or still you are having any confusion in this? Nothing is there. Just one thing you have to cross check. What you have to do? You have to take the 2 chlorobenzenes. You have to take the 2 chlorobenzenes. 2 moles of the chlorobenzenes you have to take. Now 2 moles of the chlorobenzene, we know H2SO4 heating if they have given, the first part of the H2SO4, what it will do? Removal of the H2O will take place. H2O heating, if they have given, removal of H2O, it will take place, we know. Done. And if they have given the which one? Trichloroethanol. This is, we will call it as a which one? Choral. This is a choral, right? Here if you take the H and it is a double bond. Now here it is a H. Now here it is a H. Now in this manner the H2O it will be takes place. What? In this manner the H2O will be gone. Then the H2O when it has taken. Now all the bond pair of electrons H2O it has taken. Now one bond will be moved to the this chlorine and one bond will move to the this chlorine. That option we are seeing in this one. One bond of this chlorobenzene, one bond of this chlorobenzene, and it is clear. Okay, fine, good. Right. Now you say me this one. When the CH3, CH2, CHCl2 is treated with sodium amide, the product is. Now what is the product we'll get in this one? What is the product we'll get? What is the product we'll get? What is the product we got? Answer is C. B. Answer is C. Answer is B. Answer is C. Answer is B. Answer is B. Right. Answer is a B. Yes. Answer is B. Why? Here the CH3 two times of E2 elimination. 2 times of the E2 elimination, because we are having the two chlorines, right? Here the CH2, here the CH, and here it is a 1 Cl, and here it is a 1 Cl. Yes, first 1 mole of the sodium amide is a strong base. It will readily abstract this one acidic hydrogen. When this readily abstracted this acidic hydrogen, now this bond will be shifted here and this chlorine will be eliminated. Now this is a geminal dihalide, right? This is a geminal dihalide. Now geminal dihalide, first it will produce which one? Here again we are having the H. Now here it is a, again we are having the H and we are having the Cl. Again another mole of the sodium amide. Again it will readily abstract. Again this bond will be replaced and the Cl will be eliminated. Okay, the answer is B. Answer is B. Now asterisk, you can also become the topper. Don't bull him. Okay, you can also become a topper. Right. Next one, the replacement of the chlorine of chlorobenzene to give the phenol required a drastic condition, but chlorine of 2,4 dinitrochlorobenzene is readily replaced by. This is because this type of the statement based questions only they can ask, or they will ask. Atlantic statement based questions only you will get. This type of the statement based questions only you will get. Answer, NO2 withdraw the electrons of ortho and para. NO2 withdraw the electrons at ortho and para. Now what is the question is asking? is asking the replacement of the chlorobenzene to give the phenol requires a drastic condition, but chlorine of 2,4 dinitrochlorobenzene is replaced. 2,4 dinitrochlorobenzene is replaced. This is because NO2 withdraw the electrons from ortho and para position. What is the mechanism it is involved in this? What is the mechanism it has involved in it? What is the mechanism involved in it? What is the mechanism involved in it? Do you know what is the mechanism it is involved in it? Normally, no, listen, I will explain. Listen carefully. Now, listen carefully. Here, normally, if any aromatic ring if they have given, then aromatic ring, now nucleophilic substitution or nucleophilic addition or electrophilic addition, or electrophilic addition will not show. Why? Because of the resonance of the benzene. Resonance is stabilizing the benzene very fastly, so that if it is shown the any addition reaction, it will leads to give the non-aromatic. If any chlorine also, if it is there, if any nucleophilic substitution reaction, if it want to show, this benzene pi electrons will repel that one, that I explained very clearly. Then when this benzene pi electrons are repelling that one, then when the chlorobenzene to show the nucleophilic substitution reaction with the strong -I groups, if it is attached at the ortho and para positions, what it will do? Here this bond pair of electron, when it has shifted towards this nitrogen, what it will do? Nitrogen, it will hold that negative charge very effectively to not to happen the resonance. Again this one also, this pi bond, when it has shifted here, these two nitrogens will hold what? Negative charge more effectively, and this chlorine here will get the positive charge. Then whatever the nucleophile it is there, that nucleophile it will go and attack, or whatever the, according to the question OH they have given, right? This OH minus will go and attack, and the Cl will be eliminated. When that Cl has been eliminated, now what it will get? Here it is a NO2. Now addition elimination, right? Addition elimination, and again this negative charge will be restored, again this negative charge will be restored, again the aromatic ring you will get. Addition elimination reaction, that is nucleophilic addition elimination. This is the product. So according to the question, answer D is correct. Is it clear? Is it clear for everyone? Can we move? Shall we move to the next question? Right. Very fastly you have to say me this answer. What is the answer for this one? What is the answer for this question? A is also correct then. A is also correct. NO2 makes the ring electron rich. No, electron rich they are saying. Electron rich, they will make the electron. How come the electron rich? How come the electron rich? NO2 will it give the electrons? Will it give the electrons? Will the NO2 will give the electrons at the ortho and para positions? That can hold, but it will not give. That can hold the negative charge very effectively, but it will not give the negative charge to the ring. That's what is saying. So you have to be very careful with the statement also. Next one. What is the answer for this one? Answer is B. Good. Answer is B. How? This is a Grignard reagent. Now we know the CO2 will be in this manner. Now CO2, due to the presence of this more strong 2 electron deficients. Correct only, Suhas, correct. BOA answer. Suhas answer is B only. B only. Then it will shift this bond pair of electron towards itself. Now this carbon will get the positive charge, and we know the benzyl here it will get the what positive charge, and it will form the bond. And after that, from the whatever the bond it has came, here the double bond, here the oxygen will get the negative charge. Now the H plus will be from the oxonium ion, and it will convert it into benzoic acid. Dream drive. Yes, answer is B. Right. Now, from here onwards, the level of the questions will be tricky. Not high, tricky. I am not saying you the level of the questions will be high, but the level of the questions are tricky. So, see the questions carefully and try to give the answer. Okay? These are very, very important questions. Now, what is the answer? Is the question is clear, or should I enlarge? Should I enlarge, or should I give the, should I enlarge? Is it clear? Now, what is the answer? What is the answer? Sir, answer is B. How you are saying it is a B? My dear Pranit, how you are saying it is a B? How you are saying it as a B? Because this is a tosyl chloride. SN1 reaction first and SN2 second. How the sodium azide will give you the SN2 reaction? How you get to know? How you got to know that sodium azide? Here it is in the water, right? Water they have given, right? Water is a polar protic. Water is a polar protic, right? Polar protic, if it is given, then it should do the SN1 reaction. Then how you are saying this SN2? No, answer is B only. Yes, N3 minus. N3 minus is a strong nucleophile. Good. Actually, N3 minus is a strong nucleophile. Listen. Now, the one who are in the live, now listen carefully. Actually, whenever the sodium azide they have given, sodium azide, this is a sodium azide, it will react with the water and it will be converted into the hydrozoic acid in this manner. Hydrozoic acid, and it will convert into the NaOH. Now, this sodium azide will be whatever the airbags, we know, right, in our cars, when it has hit to any collision, now very fastly this sodium azide which is present in the airbags, it will be react and it will produce the N2 gas. It will produce the N2 gas. When the collision happened or when the accident happened, due to that chemical reactions, the sodium azide which is present in the airbags, that it will react with this one and it will produce the N2 gas in the airbags. So this is the main ingredient that it will be present in the airbags, sodium azide. Remember this one. The sodium azide will be main ingredient that is present in the airbags and it will produce the N2 gas. And when this sodium azide and when it is reacted with the H2O, it will give the hydrozoic acid. Hydrozoic acid, this is a N-3. N-3 is a strong nucleophile. It will go and attack and it will give you the B. And it first one is a SN1 and second one is a SN2. So the answer is B. Right. Next one. Now this one. What is the answer for this one? This is your NEET 2021 question. NEET 2021 question. One NEET 2021 question they have given. What is the answer for this one? What is the answer for this question? What is the answer for this question? A. Answer is A. Rest any other who are in the live, anti-Markovnikov rule. This is the anti-Markovnikov rule. This is anti-Markovnikov rule because this is a organic peroxide. this organic peroxide in the presence of HBr, first it will follow the anti-Markovnikov rule, and the negative part of attacking reagent will go and attack to the carbon which contain carbon which contain more number of hydrogen, alkene carbon. Okay, done. Next. Now this one also. Oh, it has came 2 times actually. This question came, right? Okay, done. Next one. SN1 and the SN2 are. SN1 and the SN2 are the stereo specific or stereo selective. Say me the answer. What is the answer? What is the answer? What is the answer? What is the answer? Sir, should I be quit? Why? What happened? What happened, Pranit? Now, anyone in the live, try to give me the answer. What is the meaning? You want to go? SN1 reaction is a stereoselective. SN1 reaction is a stereoselective. Okay. Then SN2. Acha, you are saying that you have to be silent. Okay. Let's other two also try. Yes. When I ask you, if you know, you can say that. When I ask you, you can say. Rest others try. Okay, right. Now, SN1 is a stereoselective. And the SN2 is a stereo selective and stereo. This is stereo specific. Both SN1 is a stereo selective and stereo specific respectively. Both are stereo specific. No, both are stereo selective. Answer is both stereo selective. Both are the stereo selective. Stereo selective and stereo specific respective. No, SN1 is only stereo selective, not stereo specific. No, only. Sir, what does it mean? Stereo selective and the stereo specific means, now one it is giving the, here you can see. How I can explain? No. Right. If suppose one alkali halide, if they have given. Now here the one hydrogen, let's suppose here it is a CH3. Here it is a bromine, it is there. Now when it comes to the E1 reaction, if SN1 reaction, if it is did, SN1 reaction, it is a stable carbocation, it will generate it, right? 3 degree or chiral carbon containing alkali halide upon SN1 reaction, what it will give? Racemic mixture it will give you, right? Racemic mixture. 2 types of the product it will give. That we call it as a stereoselective. Now chiral carbon, let's suppose this is R double dash in the presence of alkali halide in the presence of aqueous. Now what it will give? Racemic mixture it will give. That type of the products we call it as a stereoselective. Then when it comes to the chiral carbon containing 1 degree alkali halide, it will give you only one product, right? Only one product it will give. That one we call it as a stereoselective as well as a stereospecific. Only one specific carbon it can attack. Only on that one specific carbon only it can attack, leads to give the product. So that one we call it as a stereospecific. So the SN1 and the SN2, stereoselective and the stereospecific. Is it clear? SN2 is a stereoselective and stereospecific, but SN1 is only stereoselective. Stereospecific, selective respectively. No, stereoselective and stereospecific respectively. So the answer is C actually, sorry. Answer is C, not B. Answer is C. Right. Next one. Now, see the compound carefully and try to give the answer. In the tomorrow's exam, this type of the questions only will be there. Either with the IUPSC, either with the logic. IUPSC or else logic. Say me the answer for this question. What is the answer for this question? Nana, Pranit, you don't try. Don't say me the answer. Rest other, if any, the who are in the live, try to give the answer. At least whether it is a correct or wrong. At least you try, so that it will also give me somewhat that you are listening. Only one is responding. I was not teaching to only him. Try to, I said you right. If you know the answer, try to say. If you don't know the answer, give me the question mark. So if you give the question mark, so that I will have some idea. So that you don't know, I can explain. So if only one is responding means, I think that he know the answer. So why to waste the time? I will not explain the mechanism and how that question it has came. Simply if you are seeing means, what you will understand. Just at least you give me the question mark, so that I can teach you on the basis of your level also. Answer is D. Rest any other? Is the answer is D? Is it correct? Rest any other? What is the reaction? Why the Nagakshaya? Why you have selected the answer D? Why not A? Why not A? Why not A? Why D? Why not A? Because if this iodine actually the answer is D. Why? Because if this iodine in the SN1 reaction, now we used to see the more stable carbocation, right? More stable carbocation, it is stabilizing by the resonance. Here it is stabilizing by the resonance. More the resonance, more will be the stable, right? So the answer is D. This is somewhat very interesting question. Now I will see who will say the first. Okay, Pranit, you can try to answer this question. I will see who will say the answer first. See how they are stressing the questions. This is a haloalkanes, haloarenes, but still they are stressing the questions with the hydrocarbons only. Now we'll see how many of you will say the correct answer. వస్తే చేయండి, రాకపోతే క్వశ్చన్ మార్క్ చేయండి. If you know the answer, try to say me. If not, give me the question mark. I will explain. Sodium amide they have given. First one is a sodium amide. Second one is a ethyl iodide. Second one is a ethyl iodide. Third one is a methyl iodide. Fourth one is a H2 palladium barium sulfate. H2 palladium barium sulfate. Two concepts it has involved in this one. Two concepts are involved in this one. Two concepts are involved in this one. Sodium amide, ethyl iodide, methyl iodide, H2PDBaSO4. H2BDASO4. Sodium amide, ethyl iodide, methyl iodide, H2PD BaSO4. H2PD BaSO4. What is the answer? What is the reason behind it? Rest any other trying? Rest any other are trying? Rest any other are trying? Rest any other are trying? Question mark. Should I explain? Should I explain? Right. B. Good Nagaksha. Good Amma. See, one thing, sir, how the ether has formed. I will explain. B only. B is the correct only. I will explain the mechanism. See, you can see, right? This is a Lindlar's catalyst. We know this should give the trans. This should give the trans. Now you can see, sorry, this should give the cis. Sorry. This should give the cis, right? This should give the cis. You can eliminate these two products by seeing itself. By seeing the last one, whenever this type of the reagents they have given, you can see this is a Lindlar's catalyst. We know Lindlar's catalyst will give you the cis one. So these two are the trans. We can eliminate among those two. Then after that, here we are having the cis. Here we are having the cis. Then among those two we have to cross check. Among those two. Then how to cross check? Now I will explain. Listen carefully. Now, first thing in that question to understand or question to give the answer, first thing you have to know CH3OH and acetylene. Which is more acidic? I explained this one very clearly. Which is more acidic? Among the one and among the two, which is more acidic? If this concept, if it is clear, you will get the answer. Among the alcohol and among the acetylene, which is more acidic? Among the alcohol and among the acetylene, which is more acidic, Amma? What happened? Among the alcohol and among the acetylene, which is more acidic? Try to give me the answer. At least you try to give me the question mark. No, one. Methyl alcohol is more acidic than the, which one? Methyl alcohol is more acidic than the acetylene. This is very key point. Methyl alcohol is more acidic than the acetylene. Why? Because oxygen holding the negative charge is more effective than the carbon holding the negative charge. Here the carbon is holding the negative charge is less than the, which one? Oxygen holding the negative charge. Oxygen holding the negative charge means this is among those two, this is a strong nucleophile. Among those two, this is a weak nucleophile. Okay, strong acids conjugate base are the weak nucleophile and the weak acids conjugate bases are the strong nucleophile, we know. Then what he has given? Sodium amide they have given, right? Sodium amide they have given. So, sorry. When the sodium amide they have given, first here it is a alcohol OH. Now here I will take this one. Now here it is a triple bond and here it is a H. Now with the 2 moles of the sodium amide, what it will do? Sodium amide it will take the acidic hydrogens. It will take, and here it will get the negative charge and here it will be the Na plus. Then here it will also, oxygen will get the negative charge, and here it will get the Na plus. Is it clear up to now? Done. Now after that, next we are having which one? Next we are having the ethyl iodide. First ethyl iodide. For this ethyl iodide, now which one is a strong nucleophile? I said which one is a strong nucleophile? CH3 C triple bond C minus is a strong nucleophile, I said, right? So first this it will go and attack to the iodine first. So that's the reason the one which is a strong nucleophile will go and attack to the which one? Ethyl very fastly, and the NAI it will be eliminated. And the next to methyl iodide we are having, right? Methyl iodine, the next nucleophile will be the oxygen. So here it will get the CH3. You will get the CH3. Then after that, which one? Then after that, we know, right? This is a Lindlar's catalyst. Lindlar's catalyst will give you the alkane will be converted into cis. Alkane will be converted into the cis. So the option number B. Oxygen got the CH3, and here the whatever the triple bond it has got, it got the ethyl. Is it clear? Is it clear? Everyone, is it clear? Is it clear, everyone? Okay, sir. Right. This one, the major product of the following reaction. 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 C, sir. Answer is C. Rest any other? Rest any other? Will you try to give the answer? Rest any other? Will you try to give the answer? Will you try to give me the answer? Ma, rest any other? Any other? Try to give me the answer. Answer A na. Hey, answer A la. No. No, answer is C. No, answer is C. Why? Because here you can see. Allylic, it will be rearranged, sir. Yes, good, Nana. Good. Nagakshay, good. Now, here, this is not this one. This is actually B. ఇక్కడ hydrogen లేదు, hydrogen ఉంది అనుకున్నారు. This is not hydrogen, this is of the B1. Now here we are having the methyl, and here we are having the OH. Then here it is a HBr, and here we are having the allylic. This oxygen lone pair of electron will be readily abstract this proton. Now oxonium ion, as the oxonium ion, H place, it will take this bond pair of electron and it will be eliminated, we know. Then after that, here it will get the what? Carbocation. Now this carbocation will be stabilized by the which one? Rearrangement. After the rearrangement, what it will happen? Right. Now here it will get the carbocation. Now the carbocation, this Br minus will go and attack, and it will give you the in this product. So the option number C is correct. Okay, allylic rearrangement will be happened. Yes. Right. Is it clear? Still you are having any confusion? Now the next question is a very beautiful question. I hope you will do. Chappan. Now try to say me the answer. Very beautiful question. What is the answer for this one? What is the answer for this question? one very beautiful question. C, sir. Naga Akshaya is saying C. Why not B? Why not B? SN1 and SN2. Naga Akshaya, how it has become? Why not B? My question is why not B? Sir, according to the SN1 deficiency polar protein, so SN1, so can be B also. Atlem ledu, can be B also. No, this is not multi-correct. This is single correct only. Multi-correct question kaadu, single correct only. Say me the answer. Answer is C. C only. Why? Because you know here this is a protic, right? This one oxygen, if it is given this H plus to this one, here it will form the stable carbocation. You can see if the carbocation is formed here, this carbocation is stabilizing by the 3 alpha hydrogens and 2 plus M effects. You can see 2 plus M effects. This carbocation is stabilizing by the 2 plus M effect. Then after that, this nucleophile is going and attacking to the which one? This carbocation and rearranges to give this one. And we know this sodium azide is a clear. Now this N3 minus is a strong nucleophile. It will go and attack in the form of the SN2. So the answer is one SN1 and the SN2. Yes, stable carbocation will rearrange. Yes, no, stable carbocation will not rearrange. There is no any rearrangement. Here the stable carbocation will form. This oxygen lone pair of electron will go and attack to this carbocation. So the answer is C. Right, good. Ijappan. I will see how many of you will say the correct answer. I will see how many of you will say the correct answer. I will see how many of you will say the correct answer. B. Good. Good, Nana, good. Answer is B. Answer is B. Why? Because this is a H2S. This H2S, when it has reacted with the 2 moles of the KOH, it will become the potassium sulfide. It will become the potassium sulfide and the H2O, it will be eliminated. Now this potassium sulfide, now it will be converted into the S minus 2. Now S minus 2, either it may be the alcohol, either it may be the alkali halides, that in the presence of S minus 2, it will rearranges to give the cyclic ring. Is it clear? The answer is B. Answer is B. Good, Nana, good. Nagakshaya, good. Good. Should I explain how it has formed? Is it clear? Should I explain? Or should I explain, or is it clear? Is it clear? Should I go to the next question? Should I explain? Rest any other who are in the live, the one who are in the live, should I explain or should I move to the next question? Explain, sir. Now, what is the option? Roughly. Okay. In it. This is a OTS, right? OTS. Done. Now OTS, we know the K2S. Now this is a potassium sulfide. This potassium sulfide will be in this manner. This is a S, this is a K, and this is a K. Now we know this OTS is a good leaving group. OTS is a good leaving group. Here it will get the positive charge. Now this will take this bond pair of electron and the O minus, and it is a TS, right? And this O minus is stabilizing by this K plus which has came from sulfur iodide. Then it will go and form the bond here. It will form the bond like this. Then again this another mole of the OTS, it will be eliminated. Again you will get the here S. Now again this bond pair of electron will be leave, sorry. Now these two are the good leaving groups, right? When these two are the good leaving groups, here it will get the positive charge. Now here the sulfur, and this is a potassium iodide, potassium sulfide, it will leave as a electropositive. Now sulfur will get the negative charge and that it will be stabilized by here. Done. Next another mole, this is a OTS is a good leaving group. Again you will get the positive charge here. Again we will get the positive charge here. Then again this sulfur, it will be this potassium, it will be eliminated, and this it will get the negative charge and it will form the bond. And if you give the numbering, you will get the B only. You will get the B only. Is it clear? Is it clear? Should I move to the next question? Yes, right. Now see the question carefully. Now I will give the numbering. Now which one is a major, you have to say me. Okay, he is asking the encircle the which of the following will undergo the SN1 SN2, he is asking, so you have to be very careful. Now in the A, this is 1 and 2, so you have to say me A whether the 1 or 2, in the B whether the 1 or 2, in the C whether the 1 or 2, now in the D whether the 1 or 2, now in the E 1 or 2. Now say me. Say me the answer. In the A 1 or 2, under among the 1 and 2, which one will readily undergo SN1, sorry SN2, which one will readily undergo SN2, which one will readily undergo SN2, which one will readily undergo SN2? Which one will readily undergo SN2? Good, Nana. In the A 1, in the A 1, yes, good. In the A 1, B, next in the B, in the B, in the B, in the B, what it will undergo? B, B2, good, B2, yes, B2, because here it will provide the more number of alpha hydrogens for the alkenes if the hydrogen is eliminated from here. Yes, B2. C, in the C, undergo SN1. In which one the SN1 reaction will undergo very fastly is asking. C, 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 no, in the C1, because here the carbocation will be stabilized and it will be resonate. Here the carbocation will form, but here the 2. So answer is 1. Answer is 1. D, 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 D undergoes SN2 reaction more rapidly. D, allylic. So D, in the D, D1, D, blindly you can believe. Bridged carbon, bridged carbon, there is no E1, there is no E2, there is no SN1, there is no SN2. Bridged carbons are unstable. So no E1, E2, SN1, SN2 for the bridged containing halides. Okay, one. E2. E. In the E, which one will readily undergoes? In the E, which one will readily undergoes? E, what is the answer? E2. Yes, good. Because here the bridged hydrogens are unstable. If this Cl, if it is want to be eliminate, if this Cl want to be eliminate, actually these compounds we can write in this manner also. Here the bridged carbons, these bridged carbons or hydrogens are unstable, right? So the answer is 2. In the E, 2. Right. Good. Right. Next one. Now see the following in these questions. This is also one beautiful question. Whatever the misconceptions that and everything you are having for your SN1, SN2, E1, E2, E1, CB, all it will be clear for you. Now here A to J, some substrates they have given. So the question is, what he is asking, the which compounds give SN2 substitution reaction on treatment with NaSH, alcoholic NaSH when you are reacting. How many of the following will be readily react with the SN2 is asking. How many of the following will be readily react with the SN2? A. For the A you have to say me the answer. Which compounds will react with the A? SN2 reaction among the A, B, C, D, E, F, G, H, I, J. How many of the following will be reacted to SN2? To SN2. How many of the following will be reacted to the SN2? Oh, say me the answer. For the A, what is the answer? How many of the among C, D, E, F, G, H, I? Answer, okay. A will not react. A will not react because this is a bridged. Simple alkali bromide will not react. Now B, 3 degree will not react. Now C will react. C will react with A. Okay, done. Now normal alkali halide, simple alkali halide will react with A. Now benzyl halide will react with SN2. A. Okay, good. Now simple SN2. Now 2 degree also 2 degree alkali halide and the cyclo 1-chloro cyclohexane also will react with A. Now G will not react. G will not react with the A. G react kadanana. Pranit, G will not react. And H will react. H will react. And I will not react. And J will not react. So only the answer for the A will be. So answer for the A will be C, D, E, F and H. Sir, how G, sir? G and I will not react because due to the presence of this steric crowd, nucleophile will not attack. nucleophile will not attack because here the steric crowd. You may think that here it is having the less steric crowd only, but here the steric crowd will repel. Steric crowd will repel, so A, it will not react. But here also steric crowd, you can see. Here also the steric crowd, here also the steric crowd. Due to the steric crowd, only the C, D, E, F, H. Only the C, D, E, F, H. Okay. Now you say me, how many of the following will be react with the E2? How many of the following will be react? Sir, inversion, so from backside, it can't come. That's what I'm saying. Right. Next for the E2. Yes, sir. Yes. So G and I will not give. G and I will not give. So the answer for the A will be C, D, E, F, H. B. What is the answer for the B? Now you have to say me for the B. Now you have to say me for the B. Now say me for the B. Now you have to say me for the B. What are the answers for the B? Which substrate will undergo very fastly in the B? E2 elimination is asking. BCF. 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 BC. Only CFIJ. IJ. B, no sir. B will give. B will give. B will give. B will give because B will be directly converted into the alkene. B will give. Yes. Now you see, B it will give, I it will not give, C it will give, E it will give, here H2, no, here E it will not give, C, F it will give, G it will give, but no, G it will not give, G it will not give, H also it will not give, G it will not give, H it will not give, and I it will give, J it will not give. So the answer will be B, C, F, I. B, C, F, I. Clear? B, C, F, I. Is it clear? Yes, B, C, F, I. That's the reason you have to cross check all the substrates they have given. What are the substrates they have given? You have to cross check. Because here the G will not give because there is no any hydrogen. Ikkada hydrogen ledu. So that's the reason it will not give. Now here the alkene will not form. Should I move to the next question? Be fast. Be fast. We have to do n number of questions. More 10 questions are there. Next, after completion of this one, we have to move to the haloalkanes, haloarenes. Haloarenes also we have to do. Okay. Should I move to the next question? Right. This one. A. What is the A here? Yes. Now say me. Now the A, this is 1. For the A, this is 1. For the now for the A, this is a 1. Now say me the answer. What are the answers for this one? This is 1, this is 2. Now this is 1, this is 2. Now this is 1, this is 2. This is 1, this is 2, this is 1, and this is 2. Now try to give me the answer. Try to give me the answer. Polar aprotic, which is a strong nucleophile. F is a strong nucleophile. I explained very clearly. Very clearly. Very clearly I explained. Fluorine. Next one. Next one. Next one. A1 is correct, B2 is correct, B2 is correct, C1 is correct. In the C1 is correct. HF and HI, strong acids, strong acid, conjugate base is weak base. Weak acid, conjugate base is strong base. So F minus is a strong base. Now D. In the D, E1, better living group. No, better living group. Better living group is 2. In E it is 2. Sulfur, it is having the vacant orbital. Sulfur, it is having the vacant orbital. This negative charge will be stabilized very fastly. But here the carbon, it does not having the vacant orbital. Carbon does not having the vacant orbital. So in the E is 2. Then D. In the D ke answer rale. I did not got the answer for D. Only I got A, I got B, I got C, I got E, I got. E2 is answer. D, what is the answer? For the D, what is the answer? No, the D is hydrazine. For the D, hydrazine is a strong nucleophile because nitrogen contains 2 lone pair of electrons. In the ammonia case, here this is the ammonia, NH3. This ammonia, when it has abstracted the proton, it will get the positive charge. Then here it is attached with the solvolysis H2O. But here the hydrazine, here the nitrogen, it is having the 2 nitrogens and it is having the lone pair of electrons. It will give you to the nucleophilic strength very fastly. So the D is 2. Hydrazine is the strong nucleophile than the ammonia. No, hydrazine. Is it clear? Right, should I move? Should I move to the next question? Is it clear? Should I move to the next question? Should I move to the next question? Should I move to the next question? Yes, sir, right. The rate of reaction given by the E2. The rate of reaction given by the E2. The rate of reaction given by the E2. The rate of the reaction given by the E2. A, B, C, D. Yes, good. Now, alkyl iodide greater than alkyl bromide greater than alkyl chloride greater than alkyl fluoride. Yes. Yes. Right. A greater than, B greater than, C greater than, D. A. A. Is it clear? A. Right. A. Alkyl iodide greater than, alkyl bromide greater than, alkyl chloride greater than, alkyl iodide. Right. Right. Okay, fine. Right. Here we are having two questions. In this reaction only we are having two questions. One is A, one is B. Now what are the answers? Read the question carefully. In the above reaction, maximum Sedgwick product will be obtained by, and in the above reaction, half-mind product is major when the X is. In this we are having the two questions. In this only A is A. Okay, A is A. Good. A is A. Then A is A. B. A is A. B. B is B. No. 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 B is a good leaving group, right? Good leaving group order. Good leaving group order: iodine, bromine, fluorine, right? D. Then it is D. Here if it is a iodine, iodine will be eliminated very fastly. So the hydrogens which are trans to each other, E1CB we used to say, right? Iodines which are good leaving groups. Chlorine also good leaving group, bromine also good leaving group. Sedgwick product is major with the, but among these four, iodine will be give the faster. Then here the half-mind product will be with the fluorine, right? You give E to A. What he is saying, it is less, right? Fluorine is a lesser. If the fluorine, if it is present, you can see chlorine, if it is here, the chlorine if it is present also, you will get the Sedgwick product only. If the bromine if it is present also, Sedgwick product only. Iodine is also present, Sedgwick product only. But only the fluorine bad leaving group, then we have to make the half-mind product only, right? Even CB it will be major. Whatever it may be, here the half-mind product will get whether the small base or the bulky base. Half-mind product only will get, right? But half-mind product with the small E2, which base will use? Either with the small base will give you the Sedgwick. Bulky base will give you the half-mind. But if the fluorine is present, either with the small base, either with the bulky base, obviously it will give which one? Half-mind only, right? Okay. So the answer A, 1 and the B, it is D. Is it clear? Or still you are having any doubts? Is it clear or still you are having any doubts? Okay, sir, done. Right. Next one. See the product carefully and try to give the answer. Sorry, see the reactant carefully and try to give the answer. Pranit, you don't give the answer. Pranit, you don't give the answer. I hope you know. I hope you know the answer. Rest other than him. I hope you know the answer. Rest any other. Rest any other. Other than him. The one who are in the live, other than him, once you try to say me the answer. If you know the answer, you can try to say. If not, give the question mark. I will explain. The one who are in the live, if you know the answer, you can say. If not, you can give the question mark. I will explain. Give the question mark. I will explain. Should I explain? Answer A. B, sir. Answer is B. Rest other? The answer is B. Answer is B. What I said, any elimination reaction to be happened, elimination reaction to be happened or E2 elimination reaction to happen, hydrogen should be anti-periplanar. Anti-periplanar. Clear? Anti-periplanar or trans switch. Periplanar, if you are getting confusion, means take it as a trans. Take it as a trans. If you see here, the already if it is in the wedge one means here the leftover will be the trans only, right? Sorry, leftover will be in the dotted only. You see leaving group and the hydrogen is cis to each other. But here the one hydrogen will be the wedge and another hydrogen will be the dotted, right? Now this hydrogen and this leaving group are cis to each other. These two are the cis to each other. But this one and this one are the trans to each other, right? Now in this manner it will go and you will get this one product. So the answer is B. Rishika, clear? క్లియర్ అయిందమ్మా? ఇది ఒక్కటి గుర్తుపెట్టుకో, హైడ్రోజన్ ఈ డాటెడ్ లో ఉన్న ఇది వెజ్ లో ఉన్నప్పుడు ఓకేనా, ఇది వెజ్ లో ఉన్నప్పుడు హైడ్రోజన్ డాటెడ్ లో ఉండాలి, ఇది డాటెడ్ లో ఉన్నప్పుడు హైడ్రోజన్ వెజ్ లో ఉండాలి. అది ఒక్కటి గుర్తుపెట్టుకో. ఓకే, రిమెంబర్ దట్ వన్. వాట్, ఇది ఒకవేళ డాటెడ్ లో ఉంది అంటే hydrogen you see it in the wedge. If it is in the wedge, see the hydrogens are in the dotted. Okay, right. So the answer is B. Here, what is the answer? Don't say, Pranit, you too don't say the answer. If you are in the live, don't say the answer. Rest others to try. What is the answer for this question? What is the answer to this question? What is the answer to this question? What is the answer? Rishika, don't know. Rest any other? Rest any other? Pranit, if you are in the live, try to give the answer. Pranit, if you are in the live, try to give me the answer. Anyone is in the live, try to give me the answer. D. Anyone in the live? Rest other? Answer is D. No reaction. What I said just now, I said you right. If the methyl, if it is in the wedge, here also methyl is in the wedge. Here the leaving group is in the dotted. Then obviously this hydrogens will be in the dotted. Obviously this hydrogens will be in the dotted. Then if these two hydrogens are in the dotted, for this leaving group, these hydrogens are cis to each other. Then there is no any trans hydrogens only. If there is no trans hydrogens, how the reaction will happen? No reaction. Clear? Clear? Right. Next one, this one. Now he has given the Fisher projection. Fisher projection, if they are given, and they are asking the alkene. Fisher projection they are given and they are asking the which alkene will be which is the alkene for this reaction. The one who are in the live, try to give me the answer. మీకు తెలిస్తే చెప్పండి. If you know the answer, try to say. If not, what is the answer? Do you know? Anyone in the live, will you try? Or should I explain? Anyone in the live? Anyone is in the live? Will you try or should I explain? Satvik B. Sir, this was there is most of C, I think. Answer is C. Yes. Answer is C. Answer is C. C only. Listen, I will explain. The only one shortcut you remember, whenever the Fisher projection, Newman projection, if they have given, if suppose the Fisher projection they have given, Fisher projection is Newman's projection eclipse. Newman projection eclipse. Clear? What he has given? He has given the CH3, here the CH3, here the H, here the pH, here the Br, and here it is a pH. Now what I said, the Fisher projection is a Newman eclipse, right? Newman projection eclipsed. Newman projection, the eclipse, how to write the Newman projection eclipsed? Now listen, Newman projection eclipse, if you see it from here, now this is a front carbon, here it is having the CH3, you can see this is a CH3. If you are seeing from the above, if you are seeing here, in this manner you are seeing, this is a CH3, now here we are having the phenyl, now here we are having the hydrogen. Okay, now back carbon, rear carbon we will represent with the circle, right? Done. Here the below we are having the CH3. Clear? Now here we are having the Br. Now here we are having the pH. Done. Then after that what we have to do? Hydrogen and the Br should be trans to each other. Then it should be the trans to each other means we have to rotate to the, how much? We have to rotate to the almost 120 degree. 120 degree rotation we have to do. Then fix the front carbon. Rotate the back carbon. This circle. This rotate the back carbon. If you rotate the back carbon by fixing the front carbon, this is CH3. This is the front carbon. This is the phenyl. Now here it is a H. Now when we rotate the back carbon, here the Br will be there. Here the Br will be there. Then here the CH3 will be there. Now here the phenyl will be there. Then after that eliminate the hydrogen and the Br. Eliminate the hydrogen and the Br. Anything you can take. Okay, I will take it from here. I will go it from here. Now, okay, I will take it from here. Listen. I will take it. Anything you can take. I will explain with the bottom one also. Now you can see here the CH3 one phenyl. Here this carbon phenyl, and here it is a CH3. Now I will go with this one. Now I will go with the bottom one. With the bottom one I will go. Now I will go from the bottom. Now if I see it from here, now the front carbon CH3, here it is having the pH, here it is having the Br. Now here it is a front carbon. Now the back carbon we are having the CH3 here. Now here it is a H, here it is a phenyl. Okay, if you are getting confusion, If you are getting, sir, why only you are writing in this manner? Why can't we write in this manner also? I will explain, sir. We cannot rotate this one. 1 minute. 1 minute. We'll try to rotate this one. Rotation is not coming. Now we can rotate this one also. If you rotate this one, if you rotate this one, actually the rotation is not coming. If you rotate it also, here the CH3, here the pH, here the iodine. Now if you take this as a rent carbon, now here it is a CH3, now here it is a Br, now here it is a pH. In this manner, both are same only. Both are same only. If you write in this manner also it is same. If you write in this manner also it is same, because this is sp3 carbon, right? sp3 carbon, it is a zigzag. sp3 carbon is a zigzag. You can rotate the carbon in any manner. You can rotate the carbon in any manner. Got it? Got it, right? Should I move to the next question? Both are same only. sp3 carbons, right? So you can rotate it in any manner. You can zigzag it. Yes. Okay. Should I go to the next question? Now say me the answer. What is the answer for this one? What is the answer for this one? Right. What is the answer for this one? Dehydrohalogenation of 2-bromobutane, which conformation leads to the formation of cis-but-2-ene. What I said? Hydrogen and the bromine should be 180 degrees. Sir, not 180. Both should be the trans to each other. Answer is A. All you will go with A only. Why not C? Pranit, why not C? Why you are choosing it as only A? Why not C? Why not C? Why? My question is, why you have chosen it as A? Why not C? Why not C? I am asking B and D you can eliminate, because both are not trans to each other. So B and D you can eliminate. But my question is, among the A and C, C will give the trans. If it is eliminated in this manner, C will give you the trans. But he is asking the cis-but-2-ene, right? Here this one will give you the cis. Okay, right. Fine. This one. Now, Fischer projection with alcoholic OH and with this Fischer projection with alcoholic OH. What is the A and what is the B? Now, in this question, answer is B. Good. Answer is B. Right. Answer is B. Yes. Here already I said, if suppose the Fischer projection they have given, try to convert into the Newman eclipse, then you cross check the halogen and the bromine. Halogen and the bromine you cross check, so answer is B. This one will give you the trans, this one will give you the cis. This one will give you the trans and this one will give you the cis. Clear? Right. See the question carefully and try to give the answer. Don't be in the hurry up. Don't be in a hurry. Don't be in a hurry to give the answer. See it and try to give me the answer. Moist Ag2O. Moist Ag2O. Amma, the one who are in the live, try to give me the answer. The one who are in the live, try to give me the answer. Only 2-3 people are responding. Rest any other who are in the live, try to at least give me the question mark so that I can say something to you. Based on your understanding of the question, I will explain. Answer is C. Because whenever the Ag, if they have given Ag when it has present, Ag it will eliminate the 2 degree alkali halide upon Ag plus ion. If they have given readily, it will take place the SN1 reaction. Readily it will take the SN1 reaction. Now the bromine will be eliminated. Now what I said, the ring adjacent carbon, if it is a positive charge, if it is added, then the ring expansion will be happened. Then the ring expansion, after the ring expansion, here the positive charge you will get. Then here the Ag2O, the base will be the OH minus. It will be in the form of the silver hydroxide. Now that it will go and attack. Now the answer is C. Yes. Ring expansion will take place. Good. Ring expansion will take place. Right. Now the correct order of aromatic electrophilic substitution reaction order is asking. Pranit, you don't say the answer. Don't say me the answer. Pranit, rest others try to say. No answer cheppakna. Rest others try to say me the answers. The one who are in the live. The one who are in the live, try to say me the answer. D. C greater than, D greater than, B greater than A. Yes. Good. This is a weak ring activating group. Now this is a neutral. Done. This is a weak ring deactivating group. This is a weak ring deactivating group. Yes. Now this one is a strong ring deactivating group. So the order will be CDBA. Right. This one. Now what is the answer for this one? Now Pranit, you can try and you can say me the answer. What is the answer for this one? What is the answer for this question? What is the answer for this question? Answer is A. Answer is A. Yes. Answer is A. Clear? No. This one you try to say me now. This is a one beautiful conversion question. Try to say me the answer. What is the answer? This is one beautiful conversion question. What is the answer? What is the answer for this question? One very beautiful question. Don't be in hurry to say the answer. See the product, see the question what is asking and try to say. Don't be in hurry to say the answer. Just see what they are asking. Don't be in hurry to say me the, don't be in hurry to say the answer. See the reaction carefully and try to give the answer. See the reaction carefully and try to give the answer. See the reaction carefully and try to give the answer. See the reaction carefully and try to give the answer. See the reaction carefully and try to give the answer. See the reaction carefully and try to give the answer. ఏమైందమ్మా ఏ సార్ ఇక్కడ యూ కెన్ సి జింక్ అండ్ హీటింగ్ ఇచ్చినాడు అంటే ఏ ఎలా వస్తుంది? ఏ కాదు, నాట్ ఏ ఈస్ నాట్ ద ఆన్సర్. రెస్ట్ ఎనీ అదర్ హూ ఆర్ ఇన్ ద లైవ్, రెస్ట్ అదర్ హూ ఆర్ ఇన్ ద లైవ్, విల్ యూ ట్రై? Rest any other who are in the live, will you try? Should I say? చెప్పనా నేను? ఏ కాదు, ఏ is not the answer. Should I say? చెప్పనా నేను? Should I say? Yes sir. Okay, right. Inan. First, this is a benzene, right? This is a benzene. This is very, very important. NTS favorite question. Listen carefully. Then they have given the which one? Benzene. And this is a C double bond O. And one anhydride they have given, right? Clear? Now, in the presence of right, Al plus 3. This is the Al plus 3. Sorry, AlCl3 hydronium ion. Now we know this is having the vacant orbital. It is having the lone pair of electron. This lone pair of electron will be given to this orbital, so that here the carbocation will be generated. Done. Then when this carbocation it has generated, how the carbocation will be generated? Now this is a carbocation will be generated. Now here it is a C double bond O. Here it will be the converted into the OH, because here the what we are having, hydronium ion we are having. At the AlCl3 it will be eliminated. In this manner the carboxylic acid it will go. Now this carbocation will go and attack to the benzene. Electrophilic substitution reaction will be happen. Okay. Sir, how the electrophilic substitution will be happen means that also I will explain. This is the negative charge. This pi bond, if it is shifted here, you will get the negative charge, you will get the positive charge. Then this carbonyl carbon, if it is attached here, the C double bond O. Now here the bond, here this one, here it is a bond, and after that here we are the bond, here we are having the carboxylic acid, here we are having the carboxylic acid, and we are having the which one? Benzene. Now again here we are having the hydrogen, again the aromaticity will be restored. After the aromaticity restored, here it is a OH, then here it is a C double bond O. Then Clemmensen reduction, we know zinc, this Clemmensen reduction will reduce, but it will not reduce the carboxylic acid. It will not reduce the carboxylic acid, right? Then when it is not reducing the carboxylic acid, then this will be eliminated. Then after that, here we are having the which one? OH. OH upon thionyl chloride. OH upon thionyl chloride, again it will become the acid chloride, right? This one will become the acid chloride. The same acid chloride again upon the AlCl3 and hydronium ion. If they have given, again what it will happen? This it will be attached to the benzene directly. Again another reaction of Friedel-Crafts acylation. Another reaction of Friedel-Crafts acylation. Is it clear? Is it clear? Or still you are having any confusion? Is it clear? The answer is B. Answer is B. Yes, sir. Right. Should I move to the next question? Should I move to the next question? Ma fatafat cheppandi. Should I move to the next question? Should I move to the next question? Yes. Cheppandi. Listen. See the substrate carefully and try to give the answer. See the substrate carefully and try to give the answer. See the substrate carefully and try to give the answer. B. Rest any other? Rest any other? Rest any other? Any other? Rest any other? Rest any other? Rest any other? Pranitya choose only the option B. Rest any other? Rest any other? Anyone who are in the live, will you go with B only? Answer is B. Good, Nana, good. Because here this is a CH3 and this is a isopropyl. Now this is H. Now the two will increase the electron density at ortho. If the CH3, it will increase the electron density at ortho and para. But among the isopropyl and among the methyl, now it will increase the electron density at ortho and para position of the benzene will be of which one? CH3. Now if any two electron releasing groups are attached to the benzene, you have to be choose that electron releasing group, which one release or which one increase the electron density at ortho and para positions. Based on that high electron releasing only we have to add. అంటే ఇప్పుడు రెండు ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్స్ బెంజిన్ కి యాడ్ అయితే ఏ ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్ అయితే బెంజిన్ కి ఎలక్ట్రాన్ డెన్సిటీని పెంచుతుందో దానికి ఆ గ్రూప్ కి ఆర్థో అండ్ పారా రెస్పెక్టివ్ అనే ఎలక్ట్రోఫైల్ యాడ్ చేయాలి. సో అమాంగ్ ద ఐసోప్రొపైల్ కి ఒకటే ఆల్ఫా హైడ్రోజన్ ఉంది కదా, ఇక్కడ 3 ఆల్ఫా హైడ్రోజన్స్ ఉన్నాయి. ఇట్ ఈస్ హ్యావింగ్ 3 ఆల్ఫా. ఇది కదా తొందరగా ఎలక్ట్రాన్ డెన్సిటీ పెంచేది. సో దిస్ ఈస్ అ నైట్రేషన్ రియాక్షన్, ఎలక్ట్రోఫైల్ విల్ బి ద NO2+. మరి దీనికి ఆర్థో పొజిషన్లోనే కదా యాడ్ చేయాలి, బికాస్ పారా పొజిషన్లో ఆల్రెడీ గ్రూప్ ఫిక్స్డ్ ఉంది. సో ద ఆన్సర్ ఇస్ బి. దట్స్ ఇట్, సింపుల్. క్లియరా? ఈజ్ ఇట్ క్లియర్? షుడ్ ఐ మూవ్ టు ద నెక్స్ట్ క్వశ్చన్? Should I move to the next question? Should I move to the next question? Should I move to the next question? Yes, sir. Right. Now try to say me the answer. Amma, by 9:30 we have to finish. By 9:30 లోపే ఫినిష్ చేయాలి. కానీ జల్దీ. What is asking? Which of the following nucleophilic aromatic reaction will be happen very fastly? Nucleophilic aromatic reaction will be happen very fastly. Nucleophilic aromatic reaction will happen very fastly. In which case? Nucleophilic aromatic reaction will happen very fastly in which case? Answer is A. 3 greater than 4 greater than 1 greater than 2. Yes. Good. Answer is A. 3 greater than 4 greater than 1 greater than 2. 3 greater than 4 greater than 1 greater than 2. Why? Because here the negative charge, this ortho position and the para positions containing strong electron withdrawing groups. Now it will hold the negative charge more effectively. So the nucleophilic substitution reaction will be happen very fastly. You can see here the ortho and para positions in the 3 we are having, but here the para position we are having, here the ortho position we are having. Means here the minus M effect is there, but here the minus M effect plus minus I effect both are there. Minus M effect and the minus I effect is there. Then after that, here the last one, the 2 meta position containing electron withdrawing groups, they will not hold that will not hold the negative charge very effectively. Ikkada mesomeric effect undadu. So the one which contain meta position containing electron withdrawing groups, it will not show the nucleophilic substitution reaction. So the answer is A. Answer is A. So 3, 4, 1, 2. This is also one beautiful question. Now try to say me the answer. Try to say me the answer. This is also one beautiful question. Try to say me the answer. What is the answer? What is the answer? What is the answer for this question? What is the answer for this question? What is the answer for this question? ఈ క్వశ్చన్ కి ఆన్సర్ ఏంటి? What is the answer for this question? Rishika is saying question mark. Rest any other? Will you try? Rest any other? Will you try? Pranit also question mark. Rest any other? Inka any other who are in the live? Question mark, question mark. Answer is A. Answer is A. How the answer is A? Now listen, I will explain. See, first they have given the benzene, right? Okay, this is a benzene. benzene, and they have given the one cyclohexene. Cyclohexene. Now in this cyclohexene, if this pi bond has been shifted here, when this pi bond has been shifted here, what it will get? Here this one will get the positive charge and this one will get the what? Positive charge and the one negative charge, right? Now we know the pi bond, we know the benzene. Benzene, this pi bond, if it is shifted here, for this benzene, if this pi bond has been shifted here, what you will get? This benzene will get the what? Negative charge, and here it is having the hydrogen, and here it is having the which charge? Here it is having the plus charge. Now this one will go and attack here. Then when it has go and attack here, now this bond will be shifted here and this hydrogen will go and attack here. Then again the benzene, it will be restored. Then after that, next reagent what they have given? NBS alkylic KOH. We know, right? NBS alkylic KOH, allylic hydrogen will be replaced and the Br will be added. Here the allylic hydrogen, because functional group adjacent carbon allylic carbon, here the Br will be added. Here the Br will be added. After the Br added, then what we are having? After the Br added, alcoholic KOH. Next we are having which one? Alcoholic KOH. Alcoholic KOH, here what it will be there? Here the HBr will be eliminated, right? Then you will get the alkene here. Then you will get the alkene here. Then after getting the alkene here, we are having the which one? R3. Sorry, not. This is a peroxide. Then you are having the peroxide. Then we are having the peroxide. Due to this peroxide, you will get the epoxide. Peroxide will give you the epoxide in this manner. So the answer is A. Is it clear? Is it clear? No. Actually, sorry. The bond will come here, I think so. Clear, sir, right? Okay, fine. ఇక్కడ బిఆర్ అటాక్ అయినాక ఇక్కడ KOH వస్తుంది. Then after that what we are having? Clear? Done? Right. Suggest the best reaction condition for the synthesis of the shown below. Now, what are the syntheses that are shown below? ఇక్కడ ఇచ్చిన దాంట్లో ఏది బెస్ట్ అని అడుగుతున్నాడు. ఏది బెస్ట్? Which one is best? Suggest the best reaction condition for the synthesis. D. Yes, D. Good. First, if you do the nitration, NO2 will come. Now NO2 is a meta-directing group, -M. Then after that, halogenation, bromination. First nitration followed by bromination. If you do the first bromination, then if you do the bromination first, what is the major product you will get? If you do the bromination first, the major product you will get it as a para-nitro word, right? Nitro you will get. Para position you will get the nitro if you do the first bromination. So to get the which one? To get the meta position, first you have to do the nitration, then followed by bromination. So answer is D, right? This one is a one beautiful question. Now try to say me the answer. This one is a one beautiful question. Try to say me the answer. Sir, why not only the bromination as reagent? Sir, why not bromine as reagent? ఏ క్వశ్చన్ అన్నా? విచ్ క్వశ్చన్ యూఆర్ ఆస్కింగ్? ఎక్కడ దేంట్లో? సార్ వై నాట్ ఓన్లీ ఆప్షన్ ఏ. ఇక్కడ బ్రోమిన్ Br2 ఇస్తే అది ఎలా? దెర్ షుడ్ బి సమ్ సాల్వెంట్, రైట్? దెర్ షుడ్ బి సమ్ సాల్వెంట్ టు జనరేట్ ద ఎలక్ట్రోఫైల్. Br2 ఇస్తే ఐదర్ H అని ఇవ్వాలి, హీటింగ్ అని ఇవ్వాలి కదా. Then radical it will undergo, but radical reaction it will not happen right here. It will undergo the electrophilic substitution. ఇక్కడ ఏమి ఇవ్వలే కదా కండిషన్. Br2 ఇచ్చినాడు అంతే, కానీ కండిషన్ ఏమి ఇవ్వలే. ద కండిషన్ he has not provided anything. This one same the answer. What is the answer? What is the answer? What is the answer? తెలుసా this question? For this question you know the answer. ఇంకొక క్వశ్చనే ఉంది. ఇది అయిపోయిందంటే ఇంకొక క్వశ్చనే, లాస్ట్ క్వశ్చన్. విల్ ఎండ్. Sir, A and B looking same, sir. No, A is 5-membered ring. A and B look same. కానీ బెంజిన్ కి ఈ పొజిషన్ లో NH2 ఉంది, ఇక్కడ ఈ పొజిషన్ లో ఉంది కదా. బెంజిన్ అడ్జసెంట్ కార్బన్ ఇది 1, బట్ బెంజిన్ కి అడ్జసెంట్ 1 లో NH2 ఉంది. A and B are not same. A and B same. So I will explain. Listen. Now the first NH2. In this NH2, ammonia. Here we are having the chlorine and we are having the Br, right? Now yesterday I explained very clearly. If suppose the H2O or any aqueous medium, if they have not given, now chlorine is a good leaving group, it will be eliminated. Then after that here the nitrogen will get the positive charge, and nitrogen it is having the hydrogens. Clear? Now here the 1 2 ఇక్కడ 1 2 and here it is a Br. Here 1, here this is a 1 2 3, 1 2 3, and here it is a which one? Br. Clear? Now again to stabilize this one, this bond pair of electron will be given. Then after that again we are having the H. Again nucleophilic addition, nucleophilic reaction will be happen again. Again this bromine will be eliminated. Clear? Again in the cyclic ring will be formed. So the answer is B. Cyclic ring form అవుతుంది ఇలా. అర్థమైందా? ఇది క్లియర్? సారీ, ఇక్కడ నుంచి కాదు, ఇక్కడ స్టెబిలైజ్ చేయడానికి. దీస్ ఆర్ ద మోర్ ఎసిడిక్ హైడ్రోజన్స్. ఇక్కడ ఈ బ్రోమిన్ సెలెక్ట్. ఇట్ విల్ గో ఇట్ ఫ్రమ్ హియర్. Now it will go it from here. And the Br will be eliminated. Okay na? Is it clear? So the answer is B. Last question. చెప్పండమ్మా, లాస్ట్ క్వశ్చన్. వాట్ ఇస్ ద ఆన్సర్? What is the answer? C. C is the answer. 5, 3, 1, 5, 3, 5, okay, first, next 3, next, okay, next is 1, okay, fine, this is 3, then after that it is a 2, then after normal one, okay, right, answer is C. Sir, this type of the questions will come tomorrow. Now, whatever this session which you have did, sir, what is SNI? Rishika, you be in online. రిషిక నువ్వు ఆన్లైన్లో ఉండు, నేను నీకు ఎక్స్ప్లెయిన్ చేస్తా. ఒక్కసారి నాకు ఒక స్టేట్మెంట్ చెప్తా. ఏవైతే క్వశ్చన్స్ మీరు చేసినారో ఇప్పుడు, వాట్ ఎవర్ ద క్వశ్చన్స్ యూ హ్యావ్ డిడ్ ఇన్ దిస్ సెషన్, రేపు ఇవే క్వశ్చన్లు ఇవే కాన్సెప్ట్తోని IUPAC నేమ్లో అడుగుతాం. గుర్తుపెట్టుకోండి, కాన్సెప్ట్ సేమే, మీకు కాన్సెప్ట్ తెలుసు కదా. IUPAC నేమ్ తెలియకపోతే మాత్రం మీకు ఆన్సర్ రావు. నెక్స్ట్ పాలిహాలోజన్ కాంపౌండ్స్ కూడా ఒకసారి చూసుకోండి. See the polyhalogen compounds also. And next, once you refer to the hydrocarbons also, refer to the hydrocarbon. First, you most convenient is refer the haloalkane, haloarenes complete notes. First, stick to the notes. Stick to the notes. Notes ki stick avandi. Notes stick అయిన తర్వాత ఇక్కడ చేసినారు కదా. This is well and enough. Now, by this, tomorrow you will get, I can expect you guys will score above 70. 70 above score చేస్తారన్న నమ్మకం నాకు ఉంది. Okay sir, ring activating and ring deactivating ones are easy only. Okay, now I will start the class of nucleophilic aromatic substitution and elimination. The one who are in the live, if they want they can, if not remaining they can leave. Rishika, న్యూక్లియోఫిలిక్ అరోమాటిక్ సబ్స్టిట్యూషన్ ఎలిమినేషన్ నీకు క్లియర్ లేదనుకుంటా, నేను ఎక్స్ప్లెయిన్ చేయనా? షుడ్ ఐ ఎక్స్ప్లెయిన్ టు యూ? Pranit, that is, the topic is clear for you, right? The topic is clear for you, right? The topic is clear? Yes sir. That if the topic, if it is clear, you can leave. ఇంటా క్లాస్ ఇంటా అంటే ఉండు, లేదంటే యూ కెన్ లీవ్. రిషిక, షుడ్ ఐ ఎక్స్ప్లెయిన్ టు యూ? రిషిక, నీకు ఎక్స్ప్లెయిన్ చేయనా? రిషిక, అది ఎక్స్ప్లెయిన్ చేయనా? అరోమాటిక్ ఎలిమినేషన్ సబ్స్టిట్యూషన్. Now the anyone, if it is in the live, anyone who are in the live, if they want to listen, they can explain, right? Explain చేస్తాను. See, all right. Now the first one in the aromatic nucleophilic substitution. First one, if any benzene, if they have given, benzene, if normally any alide, if it is attached to the benzene, then why it will not show the direct nucleophilic substitution? What is the meaning of the nucleophilic substitution in the SN1 and SN2 we used to see? If it is a 3-degree carbocation, if it is a 3-degree, carbocation will form and the nucleophile will go and attack to this one, that we are saying it as a SN1. Okay, now if it is a 1-degree, alkali halide, now what it will happen, nucleophile will go from the back end and the halogen will be eliminated, and that we are saying it as a SN2. But when it comes to the benzene, normally aryl halides, normal benzene if they have given with the halogen, nucleophile will, if directly it will not attack. Why? Because this benzene resonance, due to the benzene resonance, nucleophilic or electrophilic, both, either it may be the electrophile, either it may be the nucleophile. Nucleophile will not be attacked due to the resonance. Electrophile okavela attack ayindi ante, if the electrophile, if it is attacked, then here it will become what? then here it will become non-aromatic. Making the aromatic non-aromatic is unstable, right? So that's the reason that this is the first key step. Normally in the normal condition, nucleophilic substitution reaction, benzene will not show, or any halogens attached to the benzene will not show. So for that case, what we have to do, for that case we are having the two types of the reaction. What we are having for that case, the two types of the reaction. The first reaction we are having, that is addition elimination. బెంజిన్ కి ఇప్పుడు ఇట్లా హాలోజన్స్ ఉన్నాయంటే, హియర్ ద ఇఫ్ ద హాలోజన్స్ ఇట్ ఈస్ హ్యావింగ్, దీస్ ఆర్ ద పై బాండ్స్, రెజొనెన్స్ లో ఉంటాయి కదా ఇవి, రెజొనెన్స్ లో డ్యూ టు దిస్ రెజొనెన్స్ న్యూక్లియోఫైల్ should attack. What it will happen, this is a negative charge, this is a negative charge, it will not allow. So what we have to do then, to show the nucleophilic substitution reaction for any alkali halide, sorry not aryl halide, నాకు ఇప్పుడు చెప్పమ్మా, mesomeric effect on the benzene will be present at which and which position? Mesomeric effect on the benzene will be present on which and which positions? Mesomeric effect we can see on the benzene at which and which positions? Which positions we can see mesomeric effect? A position lo mesomeric effect చూడొచ్చు మనం. On which positions we can see the mesomeric effect on the benzene? Ortho and para kada, right? Means ortho and para positions we can see. If suppose, sorry, this is a chlorine, right? If suppose ortho substituted NO2, if they have given ortho substituted NO2, if they have given what, and the NaOH, ortho substituted NaOH, and this is a NaOH, right? Now 1 minute. Now here this is a NaOH, ortho substituted NaOH warming or warm NaOH if they have given. Here the nucleophilic substitution reaction will be happened. Why? If any ortho substituted NaOH and the para substituted NaOH if they have given, why it will happen? Because here this negative charge, when it is delocalized at the ortho position, or when this positive charge, not negative charge, when this pi bond has been shifted towards the ortho, because mesomeric effect we can see at the which positions? At ortho and para kada. Now you see this negative charge, this minus m effect will be stabilized, right? ఇక్కడ ఈ NO2 ఉండడం వల్ల ఈ నెగిటివ్ ఛార్జ్ ని మళ్ళీ డీలోకలైజ్ అవ్వడానికి ఛాన్స్ లేదు. ఇక్కడ పాజిటివ్ ఛార్జ్ వస్తుంది కదా, ఈ నెగిటివ్ ఛార్జ్ ని డీలోకలైజ్ అవ్వకుండా ఈ ఆర్థో అండ్ పారా పొజిషన్స్ లో ఉన్న NO2లు ఏం చేసేస్తున్నాయి అంటే ఆపేస్తున్నాయి. ఇప్పుడు ఈ నెగిటివ్ ఛార్జ్లని ఇక్కడ ఉన్న NO2 ఈ పై బాండ్ ని ఆపేసింది, ఇక్కడ ఉన్న NO2ని ఈ నెగిటివ్ ఛార్జ్ ఈ పై బాండ్ ని ఆపేసింది, ఇక్కడ క్లోరిన్ ఉంది, ఇక్కడ పాజిటివ్ ఛార్జ్ ఉంది. ఇప్పుడు ఏదైనా న్యూక్లియోఫైల్ వచ్చి వెరీ ఫాస్ట్లీగా అటాక్ అవ్వచ్చు కదా, ఎందుకంటే ఇక్కడ రెజొనెన్స్ లేదు, ఇప్పుడు రెజొనెన్స్ అటాకింగ్ లేదు. ఎందుకు? దిస్ NO2 అండ్ దిస్ NO2 హ్యాస్ స్టాప్డ్ ద పై బాండ్స్. ఎందుకు? అవి హోల్డ్ చేస్తాయి కదా, ఎఫెక్టివ్గా హోల్డ్ చేస్తాయి కదా. సో అందుకని ఈ నెగిటివ్ ఛార్జ్ వచ్చి ఇక్కడ అటాక్ అవుతుంది. నెగిటివ్ ఛార్జ్ వచ్చి ఇక్కడ అటాక్ అయిందంటే మళ్ళీ ఈ క్లోరిన్ ఏం చేస్తుంది, బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ తీసుకొని వెళ్ళిపోతుంది. మళ్ళీ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ తీసుకొని వెళ్ళిపోగానే మళ్ళీ ఏమవుతుంది, ఇక్కడ OH, ఇక్కడ పాజిటివ్ ఛార్జ్ వస్తుంది. మళ్ళీ ఇక్కడ NO2, ఇక్కడ నెగిటివ్ ఛార్జ్, ఇక్కడ నెగిటివ్ ఛార్జ్ NO2, డన్, ఇక్కడ బాండ్. మళ్ళీ దాని తర్వాత నెక్స్ట్ ఇక్కడ టు స్టెబిలైజ్ దిస్ నెగిటివ్ ఛార్జ్, అగైన్ ఇట్ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ విల్ బి రిస్టోర్డ్, అగైన్ ఇట్ విల్ బి రిస్టోర్డ్. అట్లా మళ్ళీ ఏమవుతుంది, ఇలా న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్ మళ్ళా అవుతుంది. ఈ ఆర్థో పొజిషన్స్లలో, ఆర్థో అండ్ పారా పొజిషన్స్లలో ఏదన్నా స్ట్రాంగ్ ఎలక్ట్రాన్ విత్ డ్రాయింగ్ గ్రూప్స్ ఉంటేనే న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్లు అవుతాయి, లేకపోతే అవ్వవు. క్లియర్ అయిందా? క్లియరా? ఈజ్ ఇట్ క్లియర్? నెక్స్ట్ another type of the question they will ask. Suppose there is no any strong electron withdrawing groups are given at the ortho and para position, will the nucleophilic substitution reactions will be happened అని అడుగుతారు. ఇప్పుడు what they will give you, they will give you this normal chlorobenzene, they will give you. Now ortho and para positions are, there is no any strong electron withdrawing group, there is no any strong any electron withdrawing group. మళ్ళీ ఒకవేళ ఇంకొక one thing you have to remember, next one, if suppose this chlorobenzene they have given and meta position NO2 if it is attached, meta position NO2 is attached, and NaOH, warm NaOH if they have given, no reaction, ఇక్కడ reaction జరగవు. why if suppose chlorobenzene if they have given and the meta position if the NO2 if they have given, reaction why it will not happen? Can you say me why the reaction will not happen? Can you say me why the reaction will not happen? Can you say me why the reaction will not happen? Rishika, can you say me the reaction, why the reaction will not happen? తెలిస్తే చెప్పు, లేకపోతే క్వశ్చన్ మార్క్ ఇవ్వు. ఇఫ్ యూ నో సే మీ ద ఆన్సర్, ఇఫ్ నాట్ గివ్ మీ ద క్వశ్చన్ మార్క్. Sir, it can't hold more effective because meta position no, what meta position there is no any in mesomeric effect. Meta position there is no mesomeric effect, so negative charge will not come at the meta position only. Meta position the negative charge it is not having any chance, so that's the reason no reaction. Okay na? Only ortho para containing nitro groups to the chlorobenzene will be react with the aromatic, which one? Aromatic nucleophilic substitution reaction very fastly. Next one, ఇప్పుడు normal chlorobenzene they have given, normal chlorobenzene. Now at the ortho and para positions there are no any which one? Now at the ortho and para positions there are no any which one we are not having, there are no any groups are attached. Even though if this type of the things are also happened, here also the reaction will be happened. How the reaction will be happened, you know, if suppose we are having the which one? Strong base. Which one? The strong base we have to take. What is the strong base? Potassium, sodium amide we know, right? Potassium amide in the presence of liquid ammonia. ఈ కేసులో we can add the nucleophile. To the chlorobenzene. ఎట్లా అంటే ఇప్పుడు చూడు, ఇక్కడ this is a hydrogens, right, for the benzene. ఈ benzene కి hydrogens. This is one very very important mechanism. Listen carefully గా క్లియర్ గా చెప్తా. రిపీటెడ్లీ దే ఆర్ ఆస్కింగ్. ఇప్పుడు ఈ సోడియం అమైడ్ కదా, ఇది పాజిటివ్ చార్జ్, ఇది నెగిటివ్ చార్జ్. ఇట్ విల్ రెడీలీ అబ్స్ట్రాక్ట్ దిస్ ప్రోటాన్ కదా, బేస్ విల్ రెడీలీ అబ్స్ట్రాక్ట్ ద ప్రోటాన్. అప్పుడు ఏమవుతుంది, ఈ బెంజిన్ మీద ఉన్న ఈ సిగ్మా బాండ్ వాట్ ఇట్ విల్ హ్యాపెన్, ఇట్ విల్ బి డీలోకలైజ్డ్. అప్పుడు ఏమవుతుంది, ఈ క్లోరిన్ ఇట్ విల్ బి ఎలిమినేటెడ్. ద క్లోరిన్ ఇస్ అ గుడ్ లివింగ్ గ్రూప్, ఇట్ విల్ బి ఎలిమినేటెడ్. అప్పుడు ఏమవుతుంది, ఇక్కడ ఏమవుతుంది, you will get the benzene mechanism in this manner. Benzene ఇక్కడ ఏం అడుగుతాడంటే this pi bond is formed by which overlapping అని అడుగుతాడు. this pi bond is formed by which overlapping, ఇది ఏ ఓవర్లాపింగ్ తో ఫామ్ అయింది, which overlapping this pi bond has been formed. sp2 sp2a, లేకపోతే ప్యూర్ p'a, లేకపోతే sp spa. తెలిస్తే చెప్పు, తెలియకపోతే క్వశ్చన్ మార్క్ ఇవ్వు. ఇఫ్ యు నో ట్రై టు సే మీ, ఇఫ్ నాట్ గివ్ మీ ద క్వశ్చన్ మార్క్. ఇఫ్ యు నో ట్రై టు సే మీ, ఇఫ్ నాట్ గివ్ మీ ద క్వశ్చన్ మార్క్. రిషిక తెలిస్తే చెప్పు, తెలియకపోతే క్వశ్చన్ మార్క్ ఇవ్వు. నో కాదు, sp2 ప్యూర్ ఆల్రెడీ ఈ దిస్ కార్బన్ హైబ్రిడైజేషన్ అదే చెప్తున్నా కదమ్మా, ఈ కార్బన్ హైబ్రిడైజేషన్ ఈస్ sp2 కదా. sp2లో ఆల్రెడీ ఒక ప్యూర్ p ఆర్బిటల్ ఉంటుంది కదా. ఆ ప్యూర్ p ఆర్బిటల్తోనే ఆల్రెడీ ఇక్కడ బాండ్స్, ఇక్కడ పై బాండ్స్ ఫామ్ అయిపోయినాయి. sp2 హైబ్రిడైజేషన్లో ఉన్న వన్ ప్యూర్ p ఆర్బిటల్తోని ఇక్కడ పై బాండ్స్ ఆల్రెడీ ఫామ్ అయిపోయినాయి. ఇక్కడ పై బాండ్స్ ఫామ్ అయిపోయిన తర్వాత లెఫ్ట్ ఓవర్ ఏంది, ఇదే కదా లెఫ్ట్ ఓవర్ వాట్ ఎవర్ ద హైడ్రోజన్ ఇక్కడ బాండ్ ఏదైతే ఫామ్ అయిందో అది sp2 ఓవర్లాపింగ్ నుంచే ఫామ్ అయింది. ఎందుకు, ఇది sp2 ఇది s కదా, ఇది కూడా sp2 ఇది p కదా. మళ్ళా దానివల్ల ఈ sp2 ఓవర్లాపింగ్ ఇక్కడ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్, ఇక్కడ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ sp2 తోనే ఇట్ ఈస్ ఫార్మింగ్. దీస్ ఆర్ ఫార్మింగ్ టు ద sp2 ఓవర్లాపింగ్. సో క్లియర్ కదా, ఇది sp2 ఓవర్లాప్ తో ఫామ్ అయ్యి దాని తర్వాత బెంజిన్ కదా, సింపుల్ బెంజిన్ కదా, ఇట్ కెన్ షిఫ్ట్ టు ద ఎనీ ఆఫ్ ద కార్బన్. ఇక్కడ NH2- ఉంటుంది, NH2- విల్ గో అండ్ అటాక్ and the H+ from the solution, it will go and attack normally. In this manner nucleophilic substitution reaction can be happened. In this manner the nucleophilic substitution reaction can be happened. Is it clear? నెక్స్ట్ ఇంకొకటి ఒక చిన్నగా ఒక రెండు ఎగ్జాంపుల్స్ రాస్తా. సేమ్ బెంజిన్ తోనే ఇప్పుడు ఇక్కడ ఒక OCH3 ఉంది, ఇక్కడ OCH3 ఉంది, ఇక్కడ క్లోరిన్ ఉంది. ఇప్పుడు నార్మల్గా మిథైల్ ఉంది, ఇక్కడ క్లోరిన్ ఉంది. ఇప్పుడు ఇక్కడ పొటాషియం అమైడ్, లిక్విడ్ అమోనియా, ఇక్కడ పొటాషియం అమైడ్, హియర్ ద పొటాషియం అమైడ్, లిక్విడ్ అమోనియా. ఇక్కడ 2 ప్రోడక్ట్స్ రాస్తా. నౌ విచ్ ఈస్ ద మేజర్, యూ హ్యావ్ టు సేమ్ ఇట్. ఏది మేజర్ అనేది నువ్వు చెప్పాలి. హియర్ NH2 ఒకటి, ఇక్కడ సెకండ్ వన్ హియర్ ద NH2. ఓకే, నౌ ఇన్ దిస్ కేస్ CH3 NH2, ఇక్కడ CH3 here NH2. Now you see this is 1 లో A మేజరా B మేజరా, 2 లో A మేజరా B మేజరా, సేమ్. In the 1 A is major or B is major? In the 2 A is major or B is major? In the 1 A is major or B is major? In the 2, in the 1 A is major. Good, because here if the benzene, if it is formed, if the here the positive charge, here this one, even though we know that this is a plus I and the minus I, but when the triple bond has formed, plus M effect will not be considered, only the minus I effect will consider. Here the plus H and the plus I, plus H effect is considered. Sir, plus H effect is not considered, but plus I effect is considered for the CH3. So in the 2 A is correct, and in the 1 is also A is correct. In the 2 A is correct, 2 la A correct, alla 1 la kuda A correct. Clear? Done? Clear? Is it clear? Anyone in the live? Rishika, is it clear? Anyone in the live? If anyone in the live, if you are having any concerns, you can ask me so that I can clarify your concerns. I will clarify your concerns. What are the concerns you are having regarding the subject or anything? Clear? Yes sir. No, live low. You are there. Pranit, you are there. I thought you went. ఓకేనా? రేపు మంచిగా క్వశ్చన్ పేపర్ని మంచిగా చూడండి, క్లియర్గా హరిబరీగా క్వశ్చన్స్ అటెంప్ట్ చేయకండి. అన్ని సింగిల్ కరెక్ట్ ఆన్సర్సే, అన్నీ చిన్న చిన్న క్వశ్చన్సే, అన్నీ మీకు తెలిసిన క్వశ్చన్సే. కాకపోతే ఐయూపీఎస్ని మంచిగా చూడండి, ఆన్సర్ని ప్రిడిక్ట్ చేయండి. సార్ డూయింగ్ క్వశ్చన్స్, ఓకే ఓకే, యూ కెన్ డూ. 3 సబ్జెక్టులను బ్యాలెన్స్ చేయాలన్నా, మ్యాథ్స్, ఫిజిక్స్, కెమిస్ట్రీ. ఇఫ్ యూ బ్యాలెన్స్ ద 3 సబ్జెక్ట్స్ ఓన్లీ, యూ విల్ గెట్ ద ర్యాంక్. ఓన్లీ మ్యాథ్స్ సార్, మ్యాథ్స్ మేడం చెప్పిందని చెప్పేసి ఓన్లీ మ్యాథ్స్, ఫిజిక్స్ సార్ చెప్పినాడని చెప్పేసి ఫిజిక్స్, ఓన్లీ కెమిస్ట్రీ సార్ చెప్తున్నాడని కెమిస్ట్రీ చేస్తే, ఆల్రెడీ ఐ ఎక్స్ప్లెయిన్ వెరీ క్లియర్లీ. ఏదన్నా 2 సబ్జెక్టులు బ్యాలెన్స్ చేస్తే మన పర్సంటైల్ అది కూడా మీకు 100 వస్తే ఎక్కడ 95లోనే ఆగిపోతాం. 95 ఇంకా కొంచెం ఎక్కువ స్ట్రెస్ చేస్తే 96లో ఆగిపోతాం అంతే. 96తో మనకేం సీట్ రాదు, 96 పర్సెంటైల్తో మనకేం సీట్ రాదు. సో ఇఫ్ యూ బ్యాలెన్స్ ద 3 సబ్జెక్ట్ ఈక్వల్లీ ఓన్లీ, యూ విల్ గెట్ ద ర్యాంక్. సరేనా? ఈక్వల్. ఇప్పుడు ఎప్పుడైనా మనకి మండే రోజు ఎగ్జామ్స్, ఎవ్రీ మండే ఎగ్జామ్ ఉంటుంది కాబట్టి ఎవ్రీ మండే ఎగ్జామ్లో ఐదర్ కెమిస్ట్రీ అయినా, ఫిజిక్స్ అయినా, మ్యాథ్స్ అయినా, కెమిస్ట్రీలోనన్నా ఈజీ చాప్టర్స్ ఉండొచ్చు, మ్యాథ్స్లో ఫిజిక్స్లో టఫ్ చాప్టర్స్ ఉంటే మ్యాథ్స్ ఫిజిక్స్కి ఎక్కువ టైం ఇవ్వాలి. ఒక్కొక్కసారి ఫిజిక్స్లో ఈజీ చాప్టర్స్ ఉండొచ్చు, సో ఆ టైంలో మ్యాథ్స్ అండ్ కెమిస్ట్రీకి ఎక్కువ టైం. ఒక్కొక్కసారి మ్యాథ్స్లో ఈజీ టాపిక్స్ ఉండొచ్చు. సో అట్లా ఆ ప్రపోర్షన్స్లల్లో మీరు ఆ బ్యాలెన్స్ చేసుకుంటే యూ కెన్ నామినల్లీ మంచి పర్సంటైల్ మెయింటైన్ చేసుకోవచ్చు. లైక్ 70 స్కోర్ చేయొచ్చు ఈజీగా అన్ని టాపిక్స్లలో, అన్ని సబ్జెక్ట్స్లలో ఈక్వల్గా. మనం ఈజీగా అబౌట్ 200, 220 మెయింటైన్ చేస్తే ఈజీగా మంచి పర్సంటైల్ పడుతుంది మనకి. ఇదే లెగసీ మంచిగా లాస్ట్ వరకు మెయింటైన్ చేసుకుంటూ పోతే ఇప్పటి నుంచే మనం స్ట్రెంగ్తెన్ చేసుకుంటే మంచిది. ఎందుకు అంటే ఒకటేసారి లాస్ట్లో రివిజన్ టైంలో మనం చదవాలంటే బర్డన్ అవుతుంది. అట్లీస్ట్ ఈ టాపిక్ సెకండ్ ఇయర్ టాపిక్స్ క్లియర్ ఉన్నా కూడా రివిజన్ టైంలో మనం వీ కెన్ స్ట్రెంగ్తెన్ ద ఫస్ట్ ఇయర్ టాపిక్స్ ఆల్రెడీ మీరు కొంచెం మర్చిపోయి ఉంటారు కాబట్టి అవి ఆ టైంలో ఎక్కువ టైం పెట్టుకుంటే మంచిగా. ఓకేనా? క్లియర్? ఓకే, ఆల్ ద బెస్ట్ ఫర్ ద టుమారోస్ ఎగ్జామ్. బాయ్. ఏం చేస్తున్నాను అన్న లైవ్? ఇంకేమన్నా ఎనీవన్ హూ ఆర్ ఇన్ ద లైవ్ ఆర్ హ్యావింగ్ ఎనీ కన్సర్న్స్? Anyone who are having in the live, they are having any concerns means you can ask. If not, I will end it. I will end the live. Should I end the live? Good night Nana, good night. Right. Bye Nana, bye. All right.